Welcome back. This is a fairly simple example using KVL, KCL, and Ohm's law. So Kirchhoff's current law, Kirchhoff's voltage law, and Ohm's law. And the methodology is a little bit haphazard, and it's really just an excuse to use those concepts, which should be a review of stuff you've seen in physics. Now, we do have better methodology later that we're going to use, but this is just a simple circuit. So we're given this circuit right here. We're given a current source, I sub G, and G you could imagine that stands for generator, and that's hooked up to a resistor, and then another couple of resistors hanging off of this away. Okay, so you got this little network here. This is a 60 ohm resistor. This is a 30 ohm resistor. This is a 90 ohm resistor. So we could, let's see, and then what else is given? This current here is given as 4 amps. And that's all that's given. So let's add some more labels for our solution. So let's call this node A, because we're going to use KCL. Let's label these voltages. Let's call the voltage here, let's call this V30. And now we have to make some guesses on polarity here, but let me throw these in here. Let's call this V90 and call this getting a little crowded, but we'll call this V60. All right, so we've got this current I sub G, which is going to come up in here and go this way, right? So some is going to split and go down this way. 4 amps of that is going to go this way. The rest of it's going to go this way. That's just what's going to happen. It's not going to come back. How to explain that? Well, just take that for now. That should sort of make sense to you, and it will make more sense when you get used to seeing more of these circuits. But basically, the current's going to go this way. Let's call that something. Let's call that I sub 0. I'm going to put it over here because it's getting kind of crowded over there. I'm going to call this I sub 0. Okay, so this I sub G comes over to the node A and splits into 4 amps and then I sub 0. So now we have the current polarities, and these are resistors, so we know that the voltage is going to be fighting those currents. So this V60 voltage is going to have this plus minus polarity in relation to the current, because that's just what resistors will always do. Likewise, if I sub 0 is going this way, then this V30 will have this plus minus polarity here, and V90 will have this plus minus polarity. All right? So you got to set that up, and then that's what's given. And what we're asked to find is I sub G, I sub 0, V sub 0, which is the voltage at the source, which is given. I left that out. I guess I sub 0 is given if they're asking you to find that as well. But anyway, there's V sub 0, and we're asked to do a power balance. Okay? The power balance just means that the power from the source should equal the power at all 3 of these loads. Okay, the methodology here, it's really just KCL, KVL, and Ohm's law in no particular order. Now, later on we have better methodology. This isn't a very complicated circuit, so we can sort of solve it willy-nilly. Just do this, do that, just try different things until you get a solution. Now, for a much more complicated circuit, that won't work. But the point here is just to introduce or review, really, KVL, KCL, and Ohm's law, which you should have seen in your physics course. So you just pick one of these guys and see what you get. Now, there is an optimal way to do it, but you don't necessarily know what that is. So let's just choose one. So let's just pick, KVL, one of these KVLs. Let's choose one. Let's go around this way and call this loop 1. Okay, so we'll pick KVL1. So the way you do KVL is you go around, you choose a direction, and the best direction to choose is the direction of the current. Go around that way, and then if you come into a negative sign, it's a negative term, and you come into a positive sign, it's a positive term. So we end up with V30 plus V90 minus V60, and those sum to 0. Because you're going around here and you're coming into this positive V30, so that's plus, and you're coming into the positive V90, so that's plus, and then coming into this negative V60, it's that. So we've got that. Now, there's 3 unknowns there. There's not much we can do with it. So let's do some Ohm's laws. Okay, so we can do Ohm's law on V60 here. In fact, that'll give us an answer. So V60. So Ohm's law is V equals IR. And we have the current 4 amps, it's given, and we have the resistance, so we'll get the voltage. So this is 4 times 60, which is IR, right? So it's 240 volts. Okay, that's not an answer, but it's a useful quantity. I like to mark that so I can find it a little bit better, easier later. Now, let's do another Ohm's law and see what we get. Let's do V30 and what happens. So V30, we don't know I sub 0, but we know the 30, so it's going to be 30 I sub 0 by, this is RI, right? 30 I sub 0, and then V90. Once again, we know the 90, but we don't know I0, so we get 90 I0. So there's a solution here, right? I've got these 3. I've got this. Yeah. So look, if you solve, solve for V60 and plug other V's in there. So this is narration. I'd like you to put into your homework. Tell me what you're doing. So solving this guy, V60 equals V30 plus V90. And we know V60 we got it's 240 volts, so we can plug these 2 guys in there. So this is 30 I sub 0, and this guy here is 90 I sub 0, and those sum to 240. So the only unknown in here is I sub 0, right? So I sub 0 is it's 240 over these 2 guys over 120, right? Just factoring out the I sub 0 and then adding the 90 and the 30 and then moving it to the other side, you get this thing. So it's 2 amps, and that's an answer. So put a box around that, because that's an actual answer that they're asking for. When I grade your homework, I'm looking for these boxes. Okay, I'm looking for these boxes. Don't make me work too hard. If you make me work too hard grading your homework, I get grumpy, and then I just start taking off points. So make it neat, please. Neater than what I do, and I know that sounds, well, shouldn't sound anything. I mean, I'm the teacher, and I'm trying. My stuff tends to be messy sometimes, but because I have a large mental load here and a time constraint. But you're the students, and what I'm asking you to do, what your job is to spend the time to organize this stuff and make it look pretty. Okay, that's what I'm asking you to do, because that means you're working the material through your brain and getting it wired in there, right? Growing those neurons so that you can do this easily, so you can think like an engineer, if that's what you want. That's what's going to happen. We're going to be trained to think like an engineer, which, there's a whole nother debate, because it's very powerful methodology, engineering methodology. That's the plus side. The downside is that perhaps everybody thinking the same isn't necessarily a good way to do it. So you sacrifice the flexibility of youth, and you sacrifice that for the power of methodology, and that's the trade-off in life in general. Anyway, what are we doing? So that's that was I0. We're asked to find V0 and IG, but we have KVL and KCL to play with. Let's try KCL at A and see what happens. So let's write a KCL for A. So we've got I sub G coming into A, and then we've got 4 amps leaving and I sub 0 leaving. So I like to write these guys as in equals out. Just, I don't know, I find it quicker to write them that way. So basically I sub G equals 4 plus I sub 0. So we know that. We know the 4 is given, and we just solve for 2. So this is 6. So that's an answer. Okay, let's use KCL at actually there's only one KCL. There's only one node here, but we have another loop we could do. We could do a loop. We could do a loop here. Call that loop 2. Okay, do a loop inside here. There's 3 loops. There's one inside here. There's one inside here. There's one around the outside. There's 3 possible KVL loops that you could draw. And like I say, we're just no particular order. We're just trying stuff just to use these guys as a review. Later on, especially in chapter 4, one of the most important chapters, we're going to learn some methodology. So for right now, just do these like this. So let's use KVL at loop 2. Okay, that's going to be so going around this way, it's going to be, we're coming into the positive V60, so it's going to be V60, and then we're going into the minus V0 equals 0, so basically V0 equals V60. And do we have V60? Yeah, we do. It's 240 volts, so that's V0. It's V0. So we got I0 and V0. We need I sub G. Did we do I sub G? Oh, we got I sub G. Oh, we're done. So we're done with that. So last is the power balance. So sort of running out of room here. So power balance. That's named after the pavilion. Used to be the Arco balance, but now it's the power balance pavilion. Used to be the Arco pavilion. So the source, the power in the source, this guy, the I sub G thingy, is so we'll use P equals IV. So this is going to be I sub G and V sub 0. So it's going to be 6 times times 240. It's going to be 1440 watts. And is it delivered or absorbed? That is this a source or a load? So then you apply the convention. You look at the arrow direction. The current's going this way, and it's going this way. So the current's coming out with a higher potential. So that's it's delivered. It's a source. All right. Then the 3 loads, 3 resistors, which are always loads. So this is the source. We did the source. Source. Okay. Then the three resistors. So the P60. You could use for this. You could use P equals I squared R, or you could use V squared over R. I mean, we have these V's, some of them anyway. We could get the others. We could get them but anyway, we have I and we have R. So this one, I squared R, is the most convenient to use. So the 60 has 4 amps in it, so it's 4 squared times 60. It's going to be 960 watts, and it's always absorbed because it's a resistor. That's what resistors do. And then the power in the 30 is it's I sub 0 squared times 30, and I sub 0 is, what is it, 2, so it's 2 squared times 30, that's 120 watts absorbed. And I mean, you could draw the arrows if you want, but the 30, you could draw the polarity arrow, so the current's going this way, and the plus minus, this is absorbed. This is the orientation for absorbed, because the current's coming out with a lower voltage potential. It's coming out at the negative sign. And the power in the 90 is also I sub 0, right? I sub 0 is going through both of these elements here, so it's 2 squared times 90. It's going to be 360 watts, and the arrows like that, it's absorbed. So do they balance? Well, basically you add up these three guys. So 960 plus 120 plus 360. These are the loads. These three loads. Do they equal 1440? And yeah, they do. So so they balance, and they must balance. The power always has to balance in these guys. If they don't balance, then one of two things happen. Either you invented a new energy source and you're going to be incredibly rich, or you made a mistake. And the latter is probably more likely. Okay. Thanks.